Okay, we're at the final session of the day, and I think you're really going to enjoy this session. As we clear the stage, I'm just going to tell you a little bit about the speaker. All the way from LA, we've got Gabriel Rene. He's the executive director of the Versus Foundation. He was just telling me backstage how they're trying to build the new web, interoperability, immersion, the ability to have a safer, more protected web for us all, using the blockchain. So I'd like to introduce Gabriel Rene and bring him on stage. Everyone, a big round of applause.
Hello, everybody. Thank you for sticking around. This is a invite-only version of the evening, so we only had about 23 passes, so a few snuck in, but thanks anyway. I want to talk to you today about evolution, but a very specific branch of evolution, a branch that, frankly, we're most familiar with, which is the branch of digital evolution. So we call this digital transformation, and really it is the transformation of the industrial world into the digital world. We heard a bit about that in the last talk. There's a lot of emerging technologies. They're popping up in your news feeds: IoT, AI, AR, VR, MR, XR, blockchain, cryptocurrencies, CRISPR, et cetera, et cetera. And so at the Versus Foundation, we wanted to help provide a context for how these technologies might work together in a way that's familiar to us, frankly, in the ways that we are currently interacting with these similar and earlier precedents of these technologies. So if you look here, this is what we call the Web 3.0 stack. And you'll notice a similarity with respect to trends. So you've got a classic sort of computer architecture here: a data layer, a logic layer, and an interface layer. So as we move from PCs into the computer network era, Web 1.0 and then 2.0, you'll notice some interesting thematics here. One is that the data layer actually becomes more and more decentralized over time, more and more trusted at a greater and greater scale. First with, I trust the data on my computer. Now I trust certain websites. Now we trust very large conglomerates, although that trust seems to be running out. And now there's an entirely new sort of form of decentralized distributed data that we call the blockchain. Although we may find it has many names over the next few decades, this idea of distributed information is part of an overall trend. In the middle, we've got this logic layer. Originally, we're sort of programming computers. Now they're beginning to program themselves. Things like smart contracts, or what you might call smarter contracts, or artificial intelligence, self-executing autonomous logic layers, smarter. At the interface layer, and this is a layer that most of us are familiar with here, we go from sort of simulations of desktops into the browser, into like mobile applications where we're using touch screens, and now we're talking, we're gesturing, we're looking. It's becoming more natural, more intuitive types of interfaces. But there is something missing as we move from this page-based computing systems to space-based computing systems. Fundamentally, AR, VR, mixed reality, extended reality, it's all about naturally interfacing with our computing information. And that information has historically been caught in these sort of page-based interfaces. And now as we move those into the real world, the fundamental question becomes, how can we trust spatial information, spatial objects, spatial data? So digital transformation is a thematic that we hear in mostly industrial frameworks. But obviously, this is the main theme of our lives with respect to all of our information. And it's really now moving into a new trend. This is a term that I want you to get familiar with. Spatialization is the ultimate stage of digital transformation. And it's really about two themes. One is about making the world digital, a digital twin for everything. We're going to walk through that in a second. Number two is making the digital more human. This is the natural and intuitive interfaces that we're talking about. So digital twins can fundamentally be anything. Virtual representations of physical objects, right? They can be the ways that we get diagnostics off an appliance, or off a vehicle, off equipment, off an electrical grid. How many people in the room have iPhone X? Please raise your hand. Yeah. So as you may or may not know, 30,000 points or so depth mapping your face that are sitting on that device. The question really becomes who ultimately can use, access, and monetize that data set. And creating digital twins of ourselves is actually starting to become a thematic, even with respect to how we're looking at medical. The new Apple Watch is going to start tracking heart rates and other things. So as we see this transition into digital health, a representation of you as a digital entity, not just as an avatar, but a hyper-realistic version of you, is becoming more and more realistic. And then there's the Internet of Things itself. So both on the industrial and on the consumer side, physical objects that are really like digital objects now. And so digital representations need an interface. The interface for the IoT is likely going to be fundamentally augmented reality. So each of these different industry trends are actually interconnected. Second theme, natural interfaces. Three-dimensional, spatial, the way we normally learn, vocal, gestural. So I'm going to burn past this because most of the folks in this room are very familiar, but just for kicks, augmented reality, the world equals a screen. Right? So now you can place anything anywhere. You can learn the history of any location. And thinking about scrubbing back and forth in time. But think about the validity and provenance of the data associated with this. How do you know that that data is accurate? It's stored on somebody's server, stored on an AR cloud service provider. How do all those work together? This is where blockchain and distributed and shared ledger technologies suddenly make a lot of sense. The how-to use of anything, obviously massive applications for AR with respect to training, and the slightly creepy background of any person. This is that Black Mirror scenario that we all kind of know is coming. 500 million cameras out there in the world, doubling at a pretty quick rate. We're talking NEC. Pretty much most of those in Asia are doing real-time facial tracking. What happens with our identity? What happens with our rights? What sort of sovereign rights do we have from a private and a public perspective? These are big questions, and it's not just who am I talking to online, but it's really who am I and what rights do the companies and governments and organizations that I'm interfacing with in the world have with respect to my data. So virtual reality is kind of the opposite, right? It's really the screen equals the world. Obviously now you can experience anything and go anywhere, and this can all occur at any scale because the laws of space and time and physics no longer apply. But what's the problem? Well, fundamentally the problem is this, right? The attention switch. Is the little black mirror the sort of pinnacle of our interfacing with technology? Everyone in this room knows that that's not the case, but we're the pioneers of a new interface, and the rest of the world is just learning about this. So fundamentally, we're talking about spatial reality because we're spatial beings. You know, millions of years of biology that have essentially tuned us. I think there were some statistics the last panel was talking about with respect to performance. In some cases, you see up to 90% higher training, learning, and retention rates. You know, with spatial interfacing. This is our natural environment. But making millions of virtual reality games or worlds or augmented reality experiences that are siloed is not the web. And the problem is the web is flat, but the world is spatial. So we think we need a new web. We think Web 3.0 is actually the spatial web. And now our information and our activities and our imaginations can be integrated into the real world. And we can be integrated into virtual domains. And those need to work interoperably and together. It's really merging the digital and the physical into a kind of unified reality. Not one where we're caught in our information and the real world is here, where this is something about something occurring in the real world. Now, information can be contextual. It's where the thing itself is. And the question is really, how do we do this? So Versus Foundation was founded about 18 months ago. We come out of backgrounds in AR and VR as early as the early 90s. Hardcore database architecture, mobile telecom technologies, patents on 3D display interfaces, kind of a pseudo Navy SEALs core group that came out of an organization called Cyberlab. We recognize over years of working with these technologies that a siloed version of the metaverse will not serve humanity and not serve the greatest purpose. So we've created a nonprofit foundation in the image of the World Wide Web, but the World Wide Web is essentially made for the interaction of people with pages and text and media, not for people, places, and things in the real world. And so we need a new set of standards, and we've developed these and we'll be releasing them next year. Now we're all familiar with web domains and HTML and HTTP, What Versus has done is created an entirely new spatial domain architecture for physical buildings, physical locations in the real world, as well as virtual domains. A new type of programming language for space which determines the rights, the policies, the permissions, and procedures with respect to how people and things interact within any space. And a new sort of protocol that allow users and objects to move between both real world and virtual spaces. So let's kind of walk through this quickly. So smart space is the big innovation here that we discovered. Programmable space for every square millimeter on the planet. Just like we made programmable pages, that was a pretty big leap from books, from magazines, right? The library essentially moved into the cloud, and the librarian was replaced with Google. And as far as the narrative of the book, from the beginning of the industrial era and the printing press until about now, this has served us really well. But now we need to address something different. We have to actually make space itself addressable. So we have a new domain architecture for this, a spatial domain registry. We've just hired recently the former CFO of ICANN. ICANN, if those don't know, is a pivotal in the birth of the web and basically the domain structure we all use today. The World Wide Web is built on top of that. We're mirroring that model, but we're using coordinates to do that. Now, spatial domain really is a shift in thinking, right? We're familiar with web domain, city museum, but what about the city museum itself? And each of the rooms within the city museum, sort of the sub-pages become subspaces. Well, this applies now to the physical city museum in the real world, in Germany in this case, but this also can apply to Hogwarts, right? You're creating a spatial domain with like subspace with a spatial URL for every point in space now allows you to go take Harry's wand, if in fact you win the prize, and move it from his room to this room. Or sell it to someone else to put in sort of virtual museum. Or send it to your nephew's house to find as a gift that then he can take into another world. Maybe fight somebody with a lightsaber. This is the kind of science fiction dreams that we've had in our books and our stories and our films. No one's ever designed the underlying technologies to make this possible that then would enable the application developers of spatial applications for virtual and augmented reality, et cetera, to build on top of, but to know that there's an interoperable framework to then let users navigate between these different spaces. So we're shifting from this idea of a web page to a web space. Fundamentally, it's XYZ coordinates with geotags that enables this to happen. You'll have to forgive me, this deck is somewhat prepared for a less sophisticated audience. So the idea here is that any object can get a universal asset ID. Blockchain enables a shared database for the world, a kind of global public utility that would enable access to tag any object or asset and create a spatial domain for any space. And then the rules within that space, essentially a new type of programming language, which we call hyperspace programming language, which uses this type of smart contract we call spatial contracts, which then determine the rules of who can see, who can search, who can interact, who can transact, and who can transport between any smart space. So here's a kind of real world example. You have a factory, smart factory of tomorrow, and this multiple clients we're talking to now would like to be able to have rules set by space. So which employees can go where at what time. Not just their ability to train in VR, AR, and get certified, that's wonderful, and you can put that on the blockchain. But now based on that certification, based on that ID, based on some sort of beacon sensor or facial recognition using AI or computer vision, confirming who is where when, and a sort of Google Analytics for real-world spaces can emerge here. Tracking of every single piece of inventory. I can't tell you how many companies we've spoken to the last couple months, large, multi-billion-dollar companies, they really don't know what's happening in their supply chain. They really have spreadsheets, and big data has caused this massive problem where they cannot make sense of this, much less set rules around how those products and objects move from the manufacturing plant to shipping to distribution and et cetera. So that comes down to the third piece here, routable. Cross-reality transport. This is probably my favorite slide of all time. This is real. So if I want to now share a virtual asset with you from one part of the world to another part of the world, or pull it from a virtual space where we've done the initial design and move it into a showroom, as you can kind of see here on the left, that's now possible because the asset has an ID, there's a spatial domain for each of those rooms, and then you use hyperspace transfer protocol to be able to move those. But also, how many people saw Ready Player One? Thank you, fellow nerds. The book was better, we all know, but that's what the hyperlink of the future might look like. How do we transport between these virtual spaces? We need an underlying language that we can all use together for this. So finally, I want you to understand sort of a breakthrough. Why blockchain? Why digital money? What does that get us? What do these have to do with each other? Well, if I haven't convinced you so far, I'd like to propose this. With Verses, you can assign a digital wallet to every person, every place, and everything. So now you can actually automate transactions based on rules that the programming language defines around how people and things move between any one location, right? Automated, real-time, smart transactions in any space. So what does that actually look like in practice? Let's say you've got a product's been manufactured. It checks to see if it's in the right truck going to the right destination. This is all referencing sort of spatial index on the blockchain. It confirms its next point. It pays the ship in order to get transport from, let's say, the port of Hong Kong to the port of Long Beach. Again, then the next automated vehicle authorizes it. Transaction happens between the product and the car itself. That could easily apply to an Uber driver. When the object is now placed inside of a warehouse, its position is known and registered on the chain, so then a user can go in, pick, pack, and shipping, whether that's a person or a robot, find exactly that item with that ID, move it, put it in the final position, where then a drone takes it to your house. Where does that drone get to land? Wherever you define, in the backyard, on the roof, in the front yard. What are the rules that define spaces? How do we make those programmatic? How does a smart city determine the flight paths for drones? Or no-fly zones, can't fly over a kindergarten, can't fly within 5 miles of an airport, or there's been some sort of terrorist threat and you need to down all drones. Right now, simply making laws that are unenforceable by code leaves us exposed to all kinds of issues, not just exposure with respect to corporations determining these rules, but actually really a question of what type of world do we want? If you can now program the world, this becomes a whole different type of question, and one that's at the heart of the implications related to the applications of what Verses is trying to support. Finally, I put the term stateful. Stateful means the ability to capture information and host it and store it in some way that's meaningful, where there's a historical record of that. Now, imagine information in augmented reality placed in space. The hours of operation on a donut shop, Krispy Kreme lets you know when hot donuts are available. Now, if someone hacks that, maybe you don't get hot donuts. But what if someone hacks the information on the on-ramp, or hacks the now augmented reality stoplights, or the electrical grid? We need to know, when there's digital twins of physical objects, that the information associated with that, the maintenance history at a nuclear facility, is trustable. So in a smart city, that could be anything, right? So you can use Verses to program a smart city with respect to how the electrical grid is sort of smart, activating and relating to the amount of traffic, some simple thing like smart parking, signage itself, and again, the provenance of data placed in critical areas where maintenance workers may be working on it. If we're digitizing the world, we must make sure that we have an interoperable layer that works like the web does now, and that cannot be owned by some independently bad actor, whether that's a government or corporation. So this may be the most important public utility that we've ever created, and it integrates the most powerful technologies simultaneously. So obviously the markets are very broad here, just like the web itself. This kind of applies to everything. How big can this get? So real world spaces, you're looking at hundreds of millions of locations. Virtual worlds, I think we all suspect billions. 1993, the web had 23 websites. There's a billion now. $1 trillion of economic power has emerged from work that was done by basically 2 guys with 1 computer over a period of a few months. These protocol architectures are the critical key to abundance. Assets, trillions of physical world assets, many of which actually are designed using Autodesk and other technologies in 3D. They're just sitting in computers somewhere. And virtual assets will be exponential. Users, well, we know we went from 0 users on smartphones to multiple billions in a period of 10 years. We forget how staggering of an adoption curve that is. With breakthroughs in ARKit and AR Core and mobile AR, we're going to see billions of potential users just in the next 2 years. As we move to headsets over the next maybe 4 or 5 years, I think we'll all be shocked 10 years looking back at the potentially billions of users and how our world may have transformed. Versus is set up as sort of 2 parts. We got the nonprofit organization, and we have labs. Labs then works with companies to help develop early stage pilots, beta testing this, sort of eating our own dog food, if you will, in order to make sure that we've architected the underlying protocols correctly. If you haven't heard about us, it's okay, we're pretty new, but in the last 6 weeks, there's about 50 press articles, TechCrunch, Entrepreneur, VentureBeat, BuzzFeed, Medium. Well, I guess Medium was just my own article, but you get the point. We are very serious about this. We do intend to, with your help, build the web of the future. We have a partnership with the VRARA Association, where we're the first strategic partner. We are looking to work with each of the committees across each chapters. Industrial, aeronautics, advertising, marketing, entertainment, working with you to help create and fund pilots that we could use as showcases to then create more awareness, adoption, and ultimately advocacy for these protocols. We have about 25 partners that have signed up in the last 6 weeks. And a little bit about the team. We've been really blessed to have some amazing people who've come out of everything from Samsung and HoloLens and Magic Leap and others to ICANN and other sort of organizations that we've been working with for a few years, actually. Our advisory board is rather stellar. Some of these names you might be familiar with. Jay Salmon is the independent vice chairman of Deloitte. Peter Diamandis is the co-founder of XPRIZE and Singularity University. Denzel Fagelson is the special advisor to Apple. Lauren Seelig, head of IMAX VR Fund. Chris Colo, our own Chris Colo, the global executive director of the VR/AR Association. Tony Parisi, global head of VR and AR at Unity. Dr. Tom Furness, a man for whom we might not be here, the grandfather of virtual reality himself, and some great partners in blockchain and AI as well. I really would like to thank the VRARA Association for this opportunity to chat with you today. Appreciate you sticking around. I'll be here for the next day and a half if you have any questions. We'd love to work with you. We're here to support you. We're looking for a world that is able, based on a couple of simple interoperability standards, to build a world of abundance for everybody, allow us to fulfill our creative visions and work together to do this. Thank you for your time.